This video is all about power rule derivative examples. So if you already watched the other video on the basics on how to use the power rule, then in this video, we're going to go over some examples. We're going to start with some very easy examples first, and then we're going to work our way to some examples that are a little bit more complicated. But before we begin, I want to remind you of a few things. The first one is, how do you write the square root of x so that it has an exponent? Well, I don't know if you remember, but the square root of x is going to be x to the 1/2 power. Just like the cube root of x is going to be x to the 1/3 power. Since we're going to be applying the power rule in questions where we see a radical, a cube root, a fifth root, we want to make sure that we take the time first to rewrite that into exponential form so that we can go ahead and have a power to apply the power rule to. If I have the cube root of x squared, then this is written as x to the 2/3 power. So that is how we deal with these square roots. The other rule of exponents that you need to remember is what happens when I have a negative exponent. If I have x to the -1, this is equal to 1 over x. Just like if I have x to the -2 power, this is equal to 1 over x squared. This rule of exponents is going to become really important in some of the exercises that we are going to do today. And then, of course, as a reminder, the derivative of a constant, if I have, for example, y equals 10, y equals 4, y equals 5, a number that has no variable next to it, just a number by itself, the derivative dy dx of any constant is just 0. Are you ready? Let's go ahead and get started. The very first example is a very easy basic case of applying the power rule to get the derivative. So here, because the question is written as f of x, I'm going to write the derivative as f prime of x. And so I'm going to get the power, which is 3, multiplied to the -6, which is -18x, and then reduce the power by 1, so I get -18x squared. Plus, I do the same thing for the 7x squared. You take the 2, you multiply to the 7, that's 14x, and then you reduce the power by 1, so that's x to the 1 power. And a lot of times we don't write x to the 1 power, so I'm not going to write it either. Then for -4x, remember that we said the derivative of a linear term is just going to be -4. And then plus 3, the derivative of a constant is 0, so that's my final answer. In number 2, before I get started on finding the derivative, I notice that I have this square root of x right here. So the first thing that I want to do is rewrite that so that way I can see a power. So I'm going to write this as 3 times x to the 1/2 power plus 5x squared minus 6. And notice that we have not actually taken the derivative just yet. All I've done is rewritten the problem. So now I can go ahead and find the derivative. I'm going to get g prime of x is equal to, I take the 1/2, multiply it by 3, that's going to be 3/2, and then I'm going to reduce the power by 1, so I get x to the -1/2 power, plus take the 2, multiply it to the 5, so plus 10, reduce the power by 1, 10x, and then of course the derivative of any constant is always 0, so that's my final answer. In number 3, we have h of t equals -1/3 t squared minus 5t plus 4 over t. So I do have to take the time first to rewrite that part so that it looks like something that has an exponent, a power to it. I'm going to start by writing -1/3 t squared minus 5t plus, and because the t is in the denominator, that means that that should be t to the -1 power. Now that I've rewritten the problem, I can go ahead and take the derivative. So I'm going to write h prime of t is equal to, take the 2, multiply to the -1/3, we get -2/3 t, and then this is just going to be minus 5. -1 times 4 is -4t, and then if I subtract 1, I get -2. This is something that if you want to, you can rewrite this as -2/3 t minus 5 minus 4 over t squared, and that's my final answer. All right, so let's go ahead and tackle question number 4. Y equals x squared plus 5 all over x. One of the things that I can do here is that I can separate this first so that I end up with x squared over x plus 5 over x. So here we have x squared over x, and this, by the rules of exponents, I'm just going to subtract. So I'm going to end up with x, because 2 minus 1 is just 1, plus, and then I'm going to rewrite plus 5 over x as plus 5x to the negative 1 power. Because according to the rules of exponents, if I have 5x to the negative 1, it's going to make it go down to the bottom to the reciprocal. So now we're going to take the derivative. And all of this, realize we haven't at all taken the derivative. We've just simplified the problem. So now I'm going to take the derivative. I'm going to write dy dx. And dy dx is going to equal, for the first part, is 1. Because this is x to the 1 power, 1 times 1 is 1. If you subtract the power, you get 0. So the derivative of x by itself is 1. Then this part, negative 1 times 5 is negative 5. And if I subtract 1, it becomes x to the negative 2 power, which, if I had to, I could rewrite as 1 minus 5 over x squared. Let's look at question number 5. Question number 5 is interesting because this is a of r. And notice that the variable here is r. A lot of times students are so used to working with x's and y's that they kind of freak out when they see another variable that's not x or y. But in this case, my variable is r. One of the things that you need to keep in mind is that pi is a number. So when you see 2 pi, you have to treat it as a number. And as a matter of fact, pi is approximately 3.14. So 2 times pi, this number is just approximately 6.28. But we're going to go ahead and leave it as 2 pi. So now when I go ahead to find the derivative, I'm going to write down a prime of r, and I'm going to find the derivative. Remember, this is my variable r. So I'm going to take the 2, I'm going to multiply that by the leading coefficient, which is 2 pi. So I get 4 pi, and if I reduce the power by 1, I get r to the 1 power. Plus, here, the power for r is 1. 1 times 4 is 4 pi, and then it just becomes r to the 0 power, so it's just 4 pi. Last but not least, the derivative of this negative 8, that's just a constant, so the derivative is 0, so that's my final answer. 4 pi r plus 4 pi. Let's look at this last problem. In this particular case, we have f of p, and we have p squared over 4 minus 13p plus the cube root of p squared. So there's a lot going on in this problem. The first thing I want to do is rewrite the beginning part. If you have p squared over 4, it's the same exact thing as saying 1/4 p squared minus 13p. Okay, there's nothing there that I have to fix. Plus, now I'm going to rewrite this as p to the 2/3 power. So once again, I have not taken the derivative just yet. All I am doing is rewriting the problem so that now I have exponents so that I can apply the power rule. So be careful with that. Now I can go ahead and take the derivative. So the derivative is going to be f prime of p is equal to, take the 2, multiply to the 1/4. 2 times 1/4 is 2/4 or 1/2. Then p, take away 1, p to the 1 power, and I don't have to write the 1 power, minus the derivative of 13p is just 13. And then here, I have to get 2/3 times the leading coefficient, which is 1. So plus 2/3 p. And if I subtract 1, 2/3 minus 1 is the same as 2/3 minus 3/3. So this is just negative 1/3. So then it's 2/3 p to the negative 1/3 power. And for the most part, you can leave the answer like that, unless your teacher wants you to kind of write it so that you get rid of that negative exponent. In which case, the final answer is going to be 1/2 p, or p over 2, minus 13 plus 2 over 3 cube root of p. And that would be your final answer. Hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.